All right, David, this is another scan that I'm going to show you, and it's the one of the R2-D2 robot. This is one of the best scans that I've ever gotten of the R2-D2 robot. This R2-D2 robot that I have is missing a piece on the top, and one of my goals was that maybe I'd be able to 3D print the missing part. And I haven't done that, but it could be done, and I'll show you what I mean. So I'm going to zoom in again. And this one only had a few orbits, which is surprising. I'm surprised how good I got at this one. This one only had maybe about 500 points. But I used my 3D, the reason why this one came out really good is I used my robot, my 3D, my video slider robot to take this. The robot moved around the R2-D2 and kept the camera pointed at it. Okay, that's the thing. This is another trade secret that I'm telling you, that you have to keep you have to tide lock. You think of in astronomy, the moon is always facing the Earth. Well, in this, the robot has to have the camera always facing the subject or the object, like let's say the robot or a person or whatever. And that's what my 3D full body scanner does. It's a robot that moves around, keeps the camera pointed at the center, perfect focus, perfect lighting, perfect settings, and just snaps the pictures uniformly so that this software, this 3D Zephyr software, can reconstruct it good. And look how it did. It really did a good job. Well, actually, sorry about that. This is the wrong one. Let me show you the other one. Okay, this is the version I meant to show you. This scan was really amazing. I used 3 orbits. It was around 500 photos total. And it was using my robot. And again, I was using the flash, my studio flash bounced off the ceiling to get uniform lighting all around. I had 2 of these, one on one side and one in the back. So this was using strobes, but bounced off the ceiling to get really uniform picture. And look at that. There's the missing part that I could 3D print. All I'd have to do is export the PLY file, and then you'd be able to make it watertight and 3D printed. And this thing is such a good scan. It wouldn't be that hard to make watertight. The only thing that's leaking here is this missing piece, but actually you would just 3D print it with that missing. That's all. And this is the cloud that it used to do it originally. So this is what Cyclops would originally give you. And then this is the dense mesh cloud. And those are all like triangles. Okay, so this is the 3D structure that you need for 3D printing. And look at that. I've totally reproduced the Star Wars R2-D2 robot. I could 3D print them myself and paint them and start selling them. Of course, Lucas would probably not like that. I've reversed engineered his toy. He probably would not like that at all. But see, then you cover it with the surface, and there it is, perfectly reconstructed R2-D2. And again, it's on this little pedestal with a Lazy Susan at the bottom. This is the key part of this invention. That plus the robot, which you don't see, that's taking all the pictures. And the robot is constantly keeping the camera faced perfectly aligned to the robot. And that's why this came out very clear versus my handheld versions, because it was very uniform. It was at the exact same distance, same radius that I orbited around this robot, and my video slider robot did all the work. It stopped, took the picture, waited 10 seconds, to take the picture, and then, or 5 seconds, I guess, so that it stabilized the tripod on it. Because that's the thing, you got to avoid vibrations. And see, that's where helicopters, if I flew around a helicopter with a camera on it, it would not get this type of detail. This is like a perfect 3D scan. You'd need a $10,000 scanner, commercial scanner, to get this kind of resolution. You need one of those LiDAR ones. But they're expensive too. They're like thousands of dollars. I built the robot with just Vex parts and scrap that I had around, as well as this Lazy Susan. So there you have it. This 3D Sapphire is an amazing product. And with my techniques, of course, like I said, these reconstructions took hours, if not a day, using my laptop, beating the heck out of my laptop. My laptop's about 5 years old. It does have a game card in it, fortunately, but it's not fast enough. It's an older technology. I have bought a NVIDIA, a better version of an NVIDIA for the PC that I have, but I need enough memory. You need like 32 gigabytes. I only had 24 gigabytes on my laptop, but you really need 32 to really have this software run very fast. And also, if I had 32, I'd be able to probably run MeshLab, which is, Meshroom, which is a software like this, but it's free. But unfortunately, it just won't run on my laptop. It just requires too many resources.